Hello, I am Rahul Mitra, a software developer with 2.3 years of experience in Android development. Today, I'd like to share one of the most impactful projects I worked on, a delayed live streaming feature for a sports streaming platform called Joymo, used by over 15 sports federations. The problem statement at hand was the application was used to stream live sporting events, but many venues had unstable internet connections. Whenever the network dropped, the livestream would fail, leading to interruptions and even loss of important match footage. So our goal was to make streaming reliable even in poor network conditions. The solution that was come up with was implementing an offline first approach where the app recorded video in small chunks and stored them locally. If the internet was available, the chunks were uploaded immediately. If the connection was lost, recording continued without interruptions, and the pending chunks were automatically synchronized with the server once the network was restored. I built this feature using Java and Kotlin and in Loom architecture, REST APIs, and background synchronization, ensuring uploads happen in the correct order. I also integrated Firebase Crashlytics with custom logging, which helped us diagnose production issues more efficiently and quickly. So now let us take a look at the high level diagram of this feature. So as we can see in our Android mobile application, we have a camera and microphone, which would be used to record the video of the uh, video using them. Then while storing the video, we would store the video not as one, but as 10-second chunks in our local storage with particular and ordered naming so that they can be used for stitching later. It's helpful for stitching later. So now this chunks would be 10 seconds. Now one can ask why 10 seconds? We arrived at this decision because 10 seconds is neither too small, neither too large. If the chunks would be too large, then during unstable internet connection, some data may be lost, and it is too small. While stitching chunks, some microseconds of data can be lost, and if there are more stitchings, as a result, more data would be lost. So now let us go to the internet yes or no situation. If the internet was down, we would continue storing chunks, and if the internet was restored, we would start uploading these chunks one by one as per the chunk names and their unique IDs using a work manager as well as a queue so that the upload is in a proper order. Now, these storing chunks would not happen independently. While creating the stream, the user can opt for a 15-minute delay or a 30-minute delay. That means, let's say the user starts the stream from 2 o'clock, but the viewers would see the stream from either 2:15 or 2:30. So let's take 15 minutes. They Now let's say 15 minutes. How many chunks would be there? 10-second chunks, 10 into 6, 60 seconds. So 1 minute would have 6 chunks, and similarly into 15. So this many chunks would be there. Now after this upload, this would use REST APIs, and we would upload this directly to AWS Blob storage. From there, based on this chunk naming as well as the file and folder location, the backend would stitch them together to make the live stream available to the users in a delayed format. But as we can say that there is no data loss due to, or maybe let's say low quality video buffering. This kind of situation are avoided. So I have some statistics for this feature resulted in. It resulted in 37% increase in active users, 22% increase in average session duration, 40% reduction in recording crashes to improved crash monitoring. Most importantly, users could continue recording events without worrying about the internet interruptions, as I said. So, closing statement. This project strengthened my understanding of offline-first mobile applications, synchronization, and building reliable user experiences under real-world network conditions. Thank you for watching. Looking forward to in the further hiring process. Thank you.